Welcome to This Is My Architecture. Today I have here Kevin from Careem. Hi Kevin.
Hello Cameron.
Can you tell me a bit more about Careem?
Yeah, so Careem started in 2012 as a ride-hailing company, and then over the next 8 years we grew to be one of the region's most successful startups. That led us to be acquired by Uber last year, and now we're expanding into an array of different services such as food deliveries, grocery deliveries, P2P transactions, payments, and that's in an attempt to become the region's leading super app.
I definitely love to use Careem. So can you tell me, so we have a very interesting architecture here. Can you tell me the use case that you were looking at?
Yeah, so essentially we wanted to build a fraud detection system that covers all of Careem. So traditionally we'd see a fraud pattern and then we'd build a project or a model specifically for that one pattern, whereas now we want like a blanket approach to cover all different types of fraud.
So can you give me an example of a fraud that happens?
Yeah, so one of the most common ones is users gaining access to stolen credit card details and then using that credit card to make purchases, book rides, do anything on the platform.
So let's dive in. Can you explain me how this works?
Yeah, so the entire project is what we call Crazy Wall. And so initially for the project, we need a database that is populated with all of our historical data about our users. So everything you see above this line here is all the historical data. So we have our data warehouse hosted on S3, running on Hive, and we then have an EMR cluster that extracts all of the data, and it uses PySpark to run an ETL pipeline which extracts, transforms, and loads the data in the format that's needed by the Neptune database. And so at the moment, once we've done all that, we have a graph database that's a historical snapshot of all our users.
That's great. So why a graph database?
So the idea behind the project is to have a representation of the identity of all of our users. So graph is a perfect way to do that, where we have users as nodes and all of their data points on their profile as nodes as well. And then users who share different data points, they'll be represented as edges in the graph.
So the data points like credit card details and those kind of things are all the edges.
Yeah, exactly.
So I know you have a few choices when you choose a graph database. Why Neptune?
Yeah, so we compared quite a number of different frameworks and we ended up choosing Neptune, firstly because, as you can see, we have a lot of different services already hosted on AWS. And secondly, Neptune is fully managed by AWS, so we don't have to worry about scalability, maintenance, backups, anything like that.
And focus on your use case, actually. So we looked into historical data. What about real-time events?
Yeah, so everything then you see below the line is the process in real time. So we have a system developed by our engineers known as Pi Event Processor, and this essentially processes every event that users perform on the app. So if they log in, if they book a ride, make a purchase, everything is processed by the system. So as these events happen, they're streamed in real time through this SQS queue into our core code base in Beanstalk. And that data is then again processed and transformed and written to the database. And then once that ride happens, it triggers a second read as well. And this read is again our core code base extracting all the data about this user and their surrounding neighbors in the graph. Once we've extracted that data, we then have a simple set of rules that run in here to try to decide whether that action performed by the user is likely to be fraudulent or not.
Okay, so what kind of accuracy are you getting from this rule-based setup?
Yeah, so it's a very simple set of rules at the moment, but we're already hitting a precision of right about 90%.
That's very impressive, yeah. Okay, and what do you do with the other 10%?
So what happens once we make a classification whether a user is fraudulent or not, the decision is written to a database, and then that decision can go one of two ways. So we have another project that measures how valuable customers are to us. So if they're a high value customer, they're added to a queue and a ticketing system to be manually reviewed. So it requires some manual intervention to see if that user should be blocked or not. Otherwise, if they're a lower value user, they're just automatically blocked by the project.
Because you don't want your high value customer to be blocked in an automated manner.
Yeah, exactly. With 90% precision, we don't want to be having 10% false positives of genuine users.
And what kind of scale are we talking about in terms of blocking?
So to date, since we launched the project, we blocked about 35,000 users.
So 35,000 bad actors.
Yeah, pretty much.
So you have many divisions within the company. How do they get benefit from this architecture that you've created?
So we built this huge graph, obviously with the intention for a fraud detection project. But obviously, once we realized we have all this wealth of data in the graph, it could be used by all different teams across Careem. So we expose the graph through an API, and this allows anyone in Careem to then query the graph, get the details about a user and their identity in the graph. So this can be used by teams in Careem for downstream tasks, such as building different machine learning models that use this data. Otherwise, another example is we have a UI, which allows anyone to view a particular user in the graph and see what they look like and who they're sharing data with.
Yep, okay. So what's next for you in terms of the architecture?
So, as I said, we have a very simple rule-based approach here, and the aim was always to add more intelligence to the system through the use of machine learning.
Yeah.
So what we're doing now for version 2 of the project is we're replacing our rules with Neptune ML. And this is a framework developed by Neptune which allows you to train deep learning models on the graph. So we're training a graph convolutional network on all the data and users in the graph. And the idea here is we'll be able to more accurately predict which users are fraudulent or not. So ideally we want to improve this 90% precision closer to 100%. And secondly, we want to improve the recall, which means we'll be increasing the number of users we block as well. And with this improved precision, if we get it high enough, we'll be confident enough to get rid of this manually review system, and then the whole project will be 100% automated.
That would be a great benefit for your company. So, so what is part of your wish list from AWS?
Yeah, so first of all, as I explained, we're integrating Neptune ML now, and that was always the plan. But before Neptune released Neptune ML, we had the plan to build this full deep learning pipeline completely in-house on our own, which would be a huge amount of work.
Yeah.
So now that Neptune has released Neptune ML, it takes a lot of the workload off of us, and we can focus on building the most powerful model possible. And secondly, a lot of our data, in a graph you have properties on both nodes and edges. And we have a huge amount of properties on both the nodes and edges, but currently most deep learning models only focus on the node properties, whereas now Neptune ML, we're working with the Neptune ML team to develop a new type of model that will also use all of these properties on edges that we have in the graph.
That makes a lot of sense. Kevin, thank you for sharing your work with me today.
Thank you, Cameron.
And thank you for joining This Is My Architecture.